Good morning. Today's topic is applications of JFET. Applications of JFET. So, as we have seen in case of transistor, two basic applications we have seen. We have seen that we can use the transistor as an amplifier. We can use transistor as a switch. So here also, in case of your JFET, we can use it as an amplifier. We can use your JFET as a switch. Okay. Now let us see that if we are comparing the JFET with respect to your transistor, which one is better and why? Say suppose if you are going for your JFET, it is simple. It will consume low power and it is small in size. So as it is small in size, consume less power. Nowadays, whatever you are having the electronic gadget, in that you will have FET only. Okay. Now you will have FET only. Okay. We are not going for transistor. Transistor means that is the old version. Okay. Now we are not going for your JFET. In JFET, we are having say your NMOS transistor. You are having PMOS transistor. Okay. There we are going. So that is the part of your FET only. That is the part of your FET only. So nowadays, what are the technology? Is the technology is revolving around your one type of your FET only. Okay. If you are going for an application, we will go for JFET as an amplifier. So here what we will do, we will compare this circuit with the previous one. That is your whatever you are having common emitter configuration. We are using common emitter configuration as amplifier. So here we are going for your common source. We will use the common source and we will see that whether we can use it for as an amplifier or not. Because your common source is equivalent to your common emitter in case of your transistor. Potential divider biasing network. Here we are using common source. Okay. Now this circuit only we will try to use it as an amplifier. Here we can go for finding your gate voltage. So what is your gate voltage? Gate voltage will be your say R2 by R1 plus R2 into your VDD. Okay, this is the external voltage across your drain with respect to your source. So from this we can calculate that what is your gate voltage. Okay. So if we are going for finding the JFET as an amplifier, we have to do the analysis. We have to go for your DC analysis and we have to go for the AC analysis. First we will go for the DC analysis. We will go for DC analysis on this circuit and we will see that whether we can use this circuit as an amplifier or not. Or if we are using this circuit as an amplifier, what are the modifications, what are the changes that we have to do. Potential divider biasing network. This potential divider biasing network, we are using it as an amplifier. When we are using it as an amplifier, in that we are going for finding your DC analysis. When we are going for finding the DC analysis, in case of your DC analysis, wherever you are having the capacitor will be open circuited. So here what is the circuit is here? Here wherever you are having the capacitor it will be open circuited, and from this your potential divider biasing network, we are getting this circuit. This is your DC equivalent circuit of that your potential divider biasing network. Here what we have done, wherever you are having the capacitor, we have open circuited the capacitor. So here you are having this capacitor, we have open circuited this one. Here you are having capacitor, we have open circuited that one. Okay, and you are having this resistor R1 and R2. These two resistors, they are connected in parallel. So as these two resistors are connected in parallel, we have taken one resistor R at the base G. This is the equivalent resistor. So this is the equivalent resistor of your this R1 and R2. So the question is, what will be the value of this equivalent resistor in terms of your R1 and R2 that you have to calculate it. And here we are having the voltage, that is your gate voltage. So gate voltage, suppose if I am going for your gate voltage, you have to calculate that what will be the gate voltage. So gate voltage here is given that it is your R2 by R1 plus R2 into your VDD. Okay, so this will be your gate voltage. So what you have to do first, you have to calculate that what will be the equivalent resistance here. Calculate that activity.